Welcome back, everyone. It has come to my attention that when you don't understand something in class, as I'm going through it like a freight train, that you're not telling me. So just tell me. Just stop the train, because chances are you're not the only one that doesn't understand what I'm doing. And that's fine. That's fine. No judgment. It's what I'm here for. So we stop the train, okay? Cool. Agreed? Okay. Okay, cool. Because, yeah, it's my goal to get you out of here early, of course, but the primary goal is to have all of you understand what's going on. Okay, so you can come back next time. All right, so today we're going to be doing a little bit of the same, but we're going to move it up to a higher dimension. We're going to be doing fractions, added to fractions on top of fractions, embedded in fractions, which is awesome. Kind of reminds me of Tropic Thunder. Fractions over fractions pretending to be other fractions. Okay, this is called complex, and I'm going to show you some examples. We're going to be using the same kind of methodology, figure out what the LCD is so that we can combine and simplify and combine and simplify. And we'll go through it. Okay, so far we've been dealing with rational expressions, some noise over some noise, okay, a polynomial over a polynomial. And we've been talking about multiplying those together. We've been talking about dividing them, where we flip the second fraction, okay, and multiplying across. And last class we did addition and subtraction of these, okay. So today we're going to be doing kind of nested operations. Okay, we're going to have a big fat main denominator bar for division, and if you're into colors or highlighters, this is a good place to use it, help you sort stuff out. But our numerator and our denominator are not just going to have plain simple old polynomials anymore. We're going to take it up an extra dimension and put fractions in there as well. Yay. Okay, it's fun. It's still a puzzle, it's still a journey, it's going to be fun. So here's some examples, all right? Notice each one of these has a big main denominator bar, okay? The big division bar in the middle, the bold one. So what we're going to be doing to tackle these is simplify as best we can the numerator and simplify the denominator, okay? Once we have a simplified numerator and a simplified denominator, we're going to take and factor out whatever we can and write our final answer. Okay. So examples, I've got a 2 and I'm adding a 1/2 and a 3 and I'm adding a 1/4. Those are complex because yes, they are rational expressions, but they have fractions up in there. Okay? These look super fun. 3x squared minus 5x, 6x squared, that's the numerator, that's the whole numerator. Yeah, it does have a division bar in there, but it is part of the main numerator. Welcome. 3 plus x over here, that doesn't have fractions in it. That's okay, doesn't have to, it's already simplified for us. But we have a complex expression in the denominator there. It's always important to point out and bold out your marker, your pencil, or whatever, that main denominator bar. So you can tackle the numerator, simplify it, combine it, and then tackle the denominator, simplify it, and then perform your division, cancel out any factors if you can. Okay. So yeah, higher dimension. Here we go. So, in order to simplify the numerator and simplify the denominator, we're using the same techniques. We're finding the LCD. Once we have an LCD, and we're just going to take it one at a time. We're going to do the numerator first, okay? LCD and the denominator, okay? And combine the numerators and combine the denominators, and then we can simplify the whole shebang, okay? So what we're going to do is take a look and find the LCD for all of the denominators that are on the problem, that are on there, okay? And what do I mean by that? Finding all of the LCD, finding all the denominators. Here we have a 5, we have an x, another 5, another x, okay? The fractions up top and the fractions down below don't have to have the same denominator. They can have all different denominators. In this case, we got a couple of repeats, so that's cool. It makes our LCD a little bit simpler. We have a 5, an x, a 5, and an x. So can anybody tell me what our LCD for this whole wagon wheel is going to be?
5x.
Yeah, it is. Pretty simple, okay? So we're looking at each of those denominators, we're lining up those factors next to each other, and we're calling that our LCD. It's kind of like we did before. I got some numbers on the board here, but when we had rational expressions and we were adding them from our last class, we took a look at the denominators of each of those expressions, and we made a list of all the factors that were involved. Then for our LCD, we took one of each of those factors. Okay. So the method here is to multiply both the numerator and the denominator of this whole complex, okay, rational expression by this LCD. And why do we do that? Well, here's what it looks like, okay? We're going to multiply this whole thing by 1. We're not going to change its value, and that's important. But we're going to multiply it by 5x up top and 5x down below. We're going to multiply the whole thing in all of its complexities by the LCD, okay? And you'll see why, and it's pretty clever and it works out, but that's what the method is, okay? So once we have, let's take a look at just the top. Okay, I have a 5x multiplied by this whole quantity. Okay, that's what we're doing. We're multiplying that whole numerator by 5x, and we're just focusing on the top of this big division bar. Okay, so to multiply that 5x in, I'm going to rainbow it into each of these terms that are connected by that negative sign, which could easily just move it up here, if that's what you're into, okay? So 5x times x divided by 5. Can you see that these 5s will cancel out? If I rainbow it in here and rainbow this in here, I'm gonna have some stuff that cancels out. And that's the beauty of this method, okay? 5x times x over 5 is gonna be x squared. Okay, and that's here. So she made, okay, so I have to put a little bit of this back on Deb, who is awesome, by the way. She's a lovely lady, but she sort of skipped the intermediate math here, and that's fine, so I'm just going to walk you through it. When we have 5x times this fraction, when we rainbow this one in, we're going to have negative 5 times 5 times x divided by x, which gets us just the minus 5 times 5, which is just this negative 25.
So did that mean that we can kind of just imagine a 1 under each of the 5 x's that were put there?
No.
No.
Oh, yes, I know what you mean.
Yes.
I know what you mean.
So that's 5x times negative 5 and then x times 1.
Yeah.
Okay.
Let me break that out a bit. Okay, so for my first fraction, I have x over 5 times 5x. And what you're saying is consider that there's a 1 in the bottom, yeah? And then multiply across.
Mm-hmm.
So my very first fraction in my numerator is going to look like this, and it's going to be this. And let me move out of your way.
Yes.
Okay? Yes.
Why is the least common denominator where it says step 2, it says x plus 5? Why
Yeah.
is it not 5x?
Not there yet. We're getting to it. Are you clear what happened in the numerator? Okay. Yeah, kind of. Okay, so we took this 5x, the LCD, the declared LCD of every single denominator in the whole expression, and we multiplied it. We rainbowed it in to to each of those terms, okay? So we're just focused on this x squared minus 25, right here in step 2. Okay, cool. You with me on that? Everybody with me on that? Okay, we're gonna get to the denominator next. When we do the denominator, we have our 5x, or 5x over 1, that helps. We're going to multiply 5x times each of these terms now, and put that in the main denominator, okay? So this green line that I've drawn here is this. The purpose of multiplying by the LCD and finding the LCD for every single denominator in this expression, the reason is because we want those fractions to drop away, okay? We want them to divide out. We want them to cancel out, which is why we chose each of these to be part of our LCD, because we want them to divide out. Okay, so for our denominator, we have a 5x. We're multiplying it times 1 over 5. What happens? That 5 cancels out. Here, let me rewrite it over here. 5x times 1 over 5. And I'm left with just x, which is here. X. Cool? Okay, so on our very last term here, 5x times 1 over x. Yes?
So the first step with the red box.
Yeah.
Solves the denominator, that solves the fractions on the top right there?
Yeah, the first step eliminated the fractions up top. And the second, down here, when we're working on the denominator, it eliminated the fractions down there, which is our goal. We're trying to simplify it. And the reason we're trying to simplify is to get rid of these fractions. That's why we chose and involved each of those denominators in our LCD. So that when we multiply our LCD in there, the denominators will divide out evenly, will cancel away. So our last term is 5x times 1 over x, and that leaves us with 5. Okay, so our denominator is there. So that's the magical thing that we're going to learn today, is take a look at each of the denominators, come up with all of our factors, all of the combined factors, and use them in our LCD, then multiply by our LCD over LCD, or 1. Rainbow that in to each term, get rid of those fractions, and then simplify further if we can. So this x squared minus 25, that's another one of your difference of squares, and that equals x plus 5 times x minus 5. Okay, coming there. Okay, go ahead.
So, I don't know if it's, well, never mind. So,
Tell you what,
it's not much of a question, it's more of a, like
you want to,
a question statement
okay, go on.
thing. Like, so, you got the complicated, or what is it called, complex?
Yeah, complex means there's fractions up top and or fractions in the bottom of the main denominator of r.
I don't know how to put it into words, but
Okay.
I guess we could have solved it right away. Is it, if the denominator, if the numerator of the denominators were both 1, and the denominators were the same as the numerators, denominators, are you following? I'm not
But-
following.
But they're not. But they're not. So the reason that we can't just jump to more simplifying this already is because this 5 is not the same as this x. And this 5 is not the same as this x.
Right.
And so these have to remain separated until such time as they look the same or we cancel them out in some clever fashion. Okay? we're gonna do, you know, we're early on in the game here, we're gonna do more examples, so we're gonna get a little bit of practice here, okay? So, here's our thing, simplify. They don't ever say please, like, wouldn't it be nice of you to simplify this, if you wouldn't mind doing that? Anyway, simplify please. That was one of my things from our last.
More
class.
like complicating it.
Well, okay, so this is the problem at hand, to simplify this, and this is the final answer, which is arguably much more simple. Okay, but anyway, how do we get there? So, our method, we take a look at each of the denominators and write out the list of all of the factors involved, including the highest power of those factors involved. So here, our factor for our very first term in the numerator is just 1, okay? Kind of disappears in there. The second one is x. I'm gonna go ahead and write it. We got an x squared here, so we're gonna need the highest power there. If we encounter any higher powers, we'll alter that. We've got a 1 covered, x covered, and an x squared covered. So our LCD is this. Okay, and we found that again by looking at all of the denominators involved in this whole mess. I'm gonna draw this guard bold so I know where we stand. Okay, so we could do this whole top as a separate problem or this whole bottom as a separate problem, but from the last slide we learned that there's kind of a shortcut here, which is called multiply by the LCD over the LCD. Okay, multiply the numerator by x squared, multiply the denominator by x squared. Okay? And so what happens is we take that x squared, we'll just focus on the top for now, and we're going to rainbow it in to each one of these terms. Okay?
Was x squared.
Anybody? Give me a hell yeah? Okay. So x squared times 1, x squared, I'm going to show you where all this happens, x squared and minus 7 over x, here's it written out here, okay, x squared rainbowed into 12 over x squared, here's it written out here. You with me? Okay, the same goes down below, x squared times this first term, here, 4 over x times our LCD, and negative 32 over x squared times our LCD.
I could distribute that, but I'm still way back in trying to see why x squared was the LCD.
Okay, okay. Well, if we take a look at every single denominator involved, we have a 1,
Yeah.
we have an x, and we have an x squared. Well, this x squared kind of covers this guy already, okay? So our LCD is a combination of each of the factors using the highest power encountered of each factor, okay? So
I
this
didn't
is-
see why those canceled out. That didn't.
Could you be more specific?
They already look the same to me.
This x and this x times x are not the same. Consider this, okay? If I had a 1 in the denominator, which I do, and I got a 3 in the denominator, which I do, and I have a 9 in the denominator, okay? Like, in other words, I've got an x and I've got an x squared in the denominator, okay? My lowest common denominator for all 3 of these has to be that 9.
Oh.
Because 9 will go into 9 evenly, 3 will go into 9 evenly, 1 will go into 9 evenly. It cannot be just x. It cannot be just 3. because 9 will not divide into that evenly. You've gotta have that higher power,
Okay.
okay? Okay, got one of them back on the train, here we go. So, we got my x squared in the denominator, bam, bam, bam. I just rewrote each one of these terms and I tacked on that x squared, I rainbowed it in. Does everybody understand this box? Good? Okay. So we're gonna do some canceling out here, it looks like. Okay, we're gonna do some multiplying, some canceling out, simplifying, if you will. At this point, once we multiply by our LCD on every single term, gets rainbowed in there, it's gonna eliminate those fractions up top, and it's gonna eliminate those fractions down below, which was the whole goal, which is the whole point. Okay. So here's our first term, x squared times 1. There it is. Check. Okay, here's this guy, 7x squared over x. That x is going to cancel out, which is the point. We want to cancel those fractions. And we got it. Don't forget that negative either, negative 7x over there. And our third term, x squared and x squared, those whole things cancel. And we're left with 12. Again, the reason for doing this method is to get rid of the fractions right away. And the reason we involved every one of these, the denominators, the factors of every one of those denominators, is so that we could cancel out the fractions in this step. Okay, cool. So down below, we've got x squared times 1. There's my x squared. I've got an x here and an x squared up top. That goes away. And I got a 4x, check. And a minus 32. All right. These polynomials look like they are ripe and ready for factoring. Yay, because everybody likes factoring quadratics. Let's see if these will go away. Okay, so for the first one, I've got a 12 down below and a negative 7. Okay, they have to be the same, they're both negative. Gives me a negative 3 and a negative 4. X minus 3 and x minus 4. Down below, I've got a 32. Let me see if I can just use my same x. I don't think that saves any time. 32, and I got a 4. And they're separate, I mean they're different signs because of this negative. So I got x minus 4 and x plus 8. So what happens here is that. Okay, so this stuff is old, old news, last episode. And this stuff, where we multiply the LCD of all of the denominators, is from today. So this is the new stuff. Okay, let's do a little bit more. Anybody want to stop here and go over this? Okay. It's going to help to do some practice. All right, so here are a few examples, okay? So up top, I've got x squared plus 5, x over 10 in the bottom. I got a fraction over a fraction. There's a couple of ways I can tackle this, because I don't have anything added. No fractions added or subtracted in the top, or added and subtracted in the bottom. This looks like something I've seen before, where I have a fraction divided by another fraction. Okay? And the way to do those is to flip the second fraction and multiply across. Okay, so I've got 10 over x times that. All right? Now, you can do it. That's probably the easiest way. Today we learned about find the LCD of all the denominators in the whole problem. In this case, the LCD would be 10. because our factors are 5 and 10. And we know that 5 goes into 10 evenly, so that's already good. So our LCD is 10 for here. If I were to follow today's method, I would multiply by the LCD up top and on the bottom. Okay, thereby canceling some stuff out. And I would have a 2x squared over x, or 2x. Alright, so that's today's method, where we multiply the LCD for all the fractions, up top and up bottom, and on the bottom. Cancel out what we can, okay? What if we did it the old-fashioned way of flipping, I'll just rewrite it over here, flipping x squared over 5 it's going to be the same thing. Okay, so there's two different ways to do this one, because we don't have many fractions up top and many fractions down below. We can do it the same old way that we've been doing dividing fractions in the past. Okay, cool. So this is just to demonstrate that today's technique works if you have only one fraction or if you have 20 fractions up top and in the bottom. Heaven forbid that happens ever, but there it is, it'll still work. Okay, let's take the LCD for this second one, okay? And we're gonna take a look at all the factors from all the denominators involved, okay? So here is one denominator, I've got an a plus 1. And my other denominator, there's only two denominators here, is 2a plus 2, which is the same as 2 and a plus 1. So my LCD for this whole shebang, anybody?
Is it 2 or is it a plus 1?
Or
Or
is it both?
am I an idiot?
Just one.
Is what?
It's
Just
just
one.
one of them.
Just one of them?
Yeah.
It's actually both.
It's both?
It is both. It is both. So, what I'm saying is, I've got to
After it's
find.
simplified, it's just the whatever it's 2. Sorry.
So it would be, the simplified version would be 2a plus 1? I mean, technically.
The not simplified
Because
version, I
it
think.
covers the a and the 1?
Yeah, so, okay, I'm looking to cover every denominator. I'm looking to cover the a plus 1, which I've got here. I've got that guy. And I'm also looking to cover the 2 that comes out of this guy. Okay, the factors of this denominator are 2 and a plus 1. So I have 2 factors involved for the whole problem. And I need both of those together to make the LCD. And the reason is because I want to cancel out both of these denominators. So I need both of those denominators to divide into the LCD evenly.
So shouldn't it be 2a plus 1?
Yes. So the LCD is 2 times a plus 1. Because my first denominator has an a plus 1 and my second denominator has an additional factor, which is 2. And I need one of each factor. Okay. So I'm going to multiply by my LCD up top and my LCD on the bottom. And you'll see that once I multiply by the whole and complete and entire LCD, that it eliminates the fractions. Okay. Tim, in this case, this can be written as 2, oh my gosh, what, why? 2a plus 1 over 1, 2a plus 1 over 1. If that helps you to understand how to multiply these across,
Cross, okay.
okay? But for now, we're gonna take that 2a plus 1 and multiply it by this 3 over a plus 1. Okay, so what is just the numerator? Does anybody see what cancels out there?
Everything?
A plus 1.
A plus 1.
The a plus 1 cancels out, right? And so what is our final numerator?
1.
This is
6.
6 and 6, 8.
6? Just 6.
Oh, I did. I just keep skipping steps.
Yep.
Will I be getting ahead of myself by saying the denom, or asking a question about the denominator?
Nope, because that's where I'm headed next.
Will it
So
just
I've got
be
to,
6A?
yep, it would be, yeah. Okay, so I've got a 2 and an a plus 1, and down here, this is the same as 2a plus 2, just factored. Same stuff. Same recipe, same cake, okay? And so this will cancel out with this. And so I have a 6a down below. Is that done?
No.
Okay, good answer. Good final answer. Okay, so once again, we have this pile of fractions. We're taking a look at all of the denominators involved. We're making a list of all the factors, and we're composing an LCD out of each one of those factors. Okay? Then we're taking and we're multiplying that factor, we're multiplying that LCD by the numerator and the denominator, and that helps us to cancel out our fractions, and we're left with something easier. Yeah.
Could you explain again how you canceled out the 2a plus 2?
Yeah, I can. So if we take a look at this 2a plus 2, can it not only be rewritten as this, it can be rewritten as 2 times a plus 1.
Oh, okay.
Yeah?
Yes.
Yeah. And we went through that factoring process when we discovered what our LCD was going to be. Just didn't write it there, but yeah, that's what that is. Okay. Should we do another one? All right, let's take a look at number 3 here. We've got a 4 and a t squared. There's my 4. Oh, let's use a different color. Colors are fun. So here is my number 3. Get rid of this. Okay. I've got a 4t squared for my first denominator. I've got a 4 and a t squared. My second denominator just has a t. Well, that t is already covered here. It's going to go into that evenly. So my LCD is just this, 4t squared. Yeah. And I know because each of my denominators, this one, 4t squared, as well as that one, t, will divide into this evenly. In other words, when we multiply by our LCD up top and our LCD on the bottom, these fractions are going to go away. Those denominators will get canceled out, which is the point, the whole point. Okay, so let's go ahead and multiply our numerator. Our new numerator. We've got this polynomial here divided by 4t squared multiplied by 4t squared. So happily, we're just going to cancel out that 4t squared, and we're left with that polynomial, t squared plus 2t minus 15. Which is going to turn into that. I'm going to go ahead and, is that cool if I write that already?
It'll still be over 4t squared in the end, right? So
Nope.
You gotta factor the
Because I
top.
left this one. So for
Yep.
the denominator though,
Denominator, that's what I was wondering. If the denominator is staying 4t squared, right?
okay. When I multiply 4t squared times this whole thing in the numerator, this 4t squared and this 4t squared go away. So all I'm left with is this. all I'm left with is this, t squared plus 2t minus 15.
The denominator went away.
So, I haven't got to the denominator here yet, but I'll put it there as soon as I do. I'm just focusing on this numerator. In fact, it's probably best to go ahead and rewrite it. T squared plus 2t minus 15. Now for my denominator, I've got t minus 3 here, and I got a t on the bottom, and I got 4 and t squared over here. So there is going to be some stuff that cancels. This is going to cancel, and that fraction is going to cancel, which is what we wanted. So I have a 4t left and a t minus 3. Okay, the whole point of this LCD over LCD is to get rid of the fractions. So it looks like I can factor that polynomial.
It's gonna be t minus 3 times t plus 5.
Yes. I know I'm in the way, but I'll move out the way. Okay, we following? Okay, and then something to do here? One more thing?
Cancel the t minus 3.
Mm-hmm. Cancel that t minus 3. And we're left with t plus 5 over 4t. Okay, so same process the whole time since the second slide here. We figure out what the LCD is for all of the denominators involved. Okay, we use one of each of the factors using the highest power that's involved. In this case, the 4t squared. Even though there was just a t right here, we gotta use that 4t squared. Okay. Multiply the top, the whole top fraction, or the whole top sum of fractions, each one of them, by 4t squared up top and 4t squared down below. And when we do the LCD, if we consider all of the denominators involved in the whole problem, then it'll cancel out our fractions. Yes?
No,
Okay. Okay. Did you figure it out?
it wasn't a question
Okay.
related to this, so I will wait until it's relevant.
Okay. Okay, cool. Let's carry on. All right, simplifying complex rational expression by dividing. Okay. Yeah, this looks a little bit like what we have been doing, okay? So previously, this is our method. Here, we don't have fractions, we have, so let me say this. Previously, we wrote this in a different way, okay? But we have done this already, okay? The way that this was written before was like this, where we have x squared minus 3x minus 40, and we've got x squared minus 9x minus 10. And we've got, what on the bottom, x squared 9x minus 8. And we've got x squared minus 100. Okay, so we've had this problem before in our homework, in our lessons. And we're rewriting it now so that it looks like this, a fraction over a fraction. Okay, same stuff, just written differently. There's ways to solve this, there's other methods. What we learned before is that since this is a division, we can take and flip this fraction and multiply across. Okay, like this. Factored it out. But we took the underneath and flipped it and multiply across. Okay, so this guy, I'm gonna not write on the board with a marker, cause I'll take that out of my non-existent pay. So, we've got, this is just rewritten here, straight across, and it's equivalent, rewritten straight across. So the other method is to factor the top box, black box, flip the underneath, the divided fraction, and factor it. Okay, this is what we've had before. We've done this. Fun with factoring. Just do it right, okay? So once we've got all these things, we can cancel stuff out, okay? Looks like we can cancel out, here's an x minus 8. Let's cancel that. We've got an x minus 10. Let's cancel that. And looks about all we can cancel. That's it. So the point of this is to say, you can have a single fat fraction up top and a single fat fraction underneath, and it's just the same as that we've done before. Okay, it's just a different way of writing it. Okay, this is different than what we've just been doing on the previous few slides, because previously we've had several fractions, 1, 2, or 3 fractions up top, 1, 2, or 3 fractions in the bottom. And we can't do it that way when we have multiple fractions, because they're attached by addition. Okay, we have to get stuff that can multiply. Are there any questions about this? This little bit of review, just a different way of writing it? Okay, so here we have one fraction here up top, one fraction down below, just like the previous slide, okay? So what's a good way to do this guy? I would take this fraction, the denominator, and flip it upside down and multiply across. Oops, oops. No, not that guy. Okay, I just took this guy and I flipped him and I multiplied. Yes?
Are there gonna be certain times when we do and do not wanna flip it like that, or is it just whenever we want, like whatever's easiest?
Well, the answer is whatever's easiest, and whatever's easiest is what you're allowed to do, basically. So, and what do I mean by that? Here, since you only have one fraction here and one fraction here, you can take this, flip it upside down, and multiply across, and that works. But you can't do that here, okay? And it doesn't help you, okay? It's best to combine these fractions first, and combine any if there are here, whatever. Get rid of the fractions by multiplying by that combined LCD, and then simplifying down, okay? You see how that's why they're different. Okay, this is a fraction over a fraction, which is take that second fraction, flip it over, and then do the factoring that we all know and love by now, and cancel things out. Okay, so this line right here is just rewritten. Same. Okay, took the second fraction, flipped it upside down, and now I have some things to factor, some things that I can't factor. But let's be clear here what we're doing. Those parentheses are important. Keep them. Okay, is this clear what happened here? We're going to factor this x squared minus 16 here. This 2x plus 3 remains the same. X minus 4 remains the same because I can't factor those anymore. And 4x minus 9 is another difference of squares. It's 2x plus 3. 2x minus 3. Okay, cool. And here we can factor some stuff out, or we can divide stuff out, cancel, 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 and that's our final answer. Okay, so again, this is a little bit of review. It's just like the last slide. We have stuff up top, we flip the second fraction, and now we can factor out, cancel where we can, okay? One step at a time. This is the new stuff that we learned today, which is take a look at each of these denominators involved, factor each of those denominators involved, make a list of all those factors. We got an x, I got an x minus 1, and I got another x minus 1. So what is our LCD for that whole black box? The LCD is a combination of each of the denominators. Pardon?
No, there's nothing.
Say again? Again for the people in the back. There it is. There it is, that's our LCD. It's one of each of the factors of all the denominators. Thank you. Okay, so once we know our LCD, we can take our LCD that we just figured out. Let me write this in a different color here. Scooch, scooch, scooch. We can take our LCD that we just learned, okay? This is our LCD. And multiply it times the top and times the bottom. And, wow, colors, but there's our fun. This guy, and x times x minus 1, okay? So again, the reason that we're doing that, multiplying by the LCD of all the denominators up top and also on the bottom, is to get rid of these ugly fractions, okay? So that's exactly what happens. We're gonna do it yellow, green, and blue. We're gonna multiply x times x minus 1 times the yellow here, yellow, x times x minus 1 times the green over there, and the blue on the bottom. Okay, and we will find that stuff starts to cancel away. More importantly, we get rid of the fractions, which is the whole point again. Okay, let's cancel this x and this x. And we're going to cancel this x minus 1 and this x minus 1. How about on the bottom? What are we canceling?
X minus 1.
Thank you. Good. Sometimes we need to check in. Okay. So what happened is that all those fractions went away. Awesome. And we're left with some pink boxes that disappear magically. Okay. So here we have only an x minus 1 left. There is a 1 multiplied by it, but that 1 disappears. It's just a 1. Sad and alone, all by himself. 2, and x is right here. Here it is, and this, and this. And down below we have a 4, and an x, and there's my 4x. How are we feeling? Understand this? We're repeating the same method. Okay, cool. So here's some that from our past, which was fun. Here's our new stuff. Look at each denominator, select all the factors involved, create our new LCD, multiply by our new LCD up top and on the bottom. Okay, we good? I'll be here all night. Okay. Okay, this looks pretty simple at first glance, but you know what? It's not. Because a to the minus 2 power, does anybody remember what that looks like? Another way to write that?
1 over a to the second power.
Yes, correct. 1 over a to the second power. And the same with this guy, 1 over b, right? Remember this? This is going back a little bit. So we got fractions up top, and yeah, we're gonna have fractions down here too, okay? So it looks simple, but it's not. We gotta make fractions out of them. Is there any questions on this? This should be a little review, going back a little while from before I was born. Yeah.
Why not just make it so it's a minus 5b on the top? Why not just flip it and rewrite it so it's instead of the a minus 2 power, words, instead of the a to the power of minus 2 plus b to the minus 1, why wouldn't it be a minus 5b to the third power divided by a to the second power plus b? Like flipping them.
Oh, I understand. Why not have, why isn't this equal to a plus, a minus 5
Yeah.
b third over a squared plus b? Because, so the reason is that each one of these is its own individual fraction, its own individual entity, okay? So it doesn't work that way. It looks like this and it's not this,
Okay.
okay? I could probably take a long side trip down this
You're good.
memory lane,
Keep
but
going.
but yeah, this
taking-
is not the same. Nobody do this.
very.
Negative. Don't look at this. Forgot you ever saw this. It's not real. This is how it works. You laughing? That's all right. Okay. But in any case, despite the fact that we may not be able to go into that particular country right now and take a look at why that is, does everybody understand where this came from? Okay, this is a little bit of exponents from yesteryear. Okay, cool. All right, so again, we've got fractions up top and fractions down below. We have our big main, let's not forget about him. So we gotta take a look at all of the denominators involved and make a list of all of their factors and come up with an LCD, okay? So we've got an a squared, okay? We've got a b, we've got an a, that's covered in this one, okay? And we've got a b to the third power. Well, I need that one then. Need the highest power. Okay, so here it is. This is our LCD. Okay, does everybody understand how we came up with that? Okay, we went and looked at each one. All right, took the highest power. There it is. Now we're going to take that LCD and multiply top and bottom. A squared b to the third, a squared b to the third. We multiply by 1 so that we don't change the value of this expression. Because we're not trying to solve, we're just trying to simplify it. We don't want to change it, we just want it to look simpler. So LCD over LCD, some stuff is going to cancel. When we rainbow this in, this a squared b to the third, to each one of these, this is what it looks like. Okay, so for the first one, and I won't do all these, but the first one, a squared b to the third, rainbowed into this first term, 1 over a squared. That's how we write that. LCD times the second term, and down in the denominator, each term gets represented as well. So we got 4 terms in this, one main division bar. And the reason that we did this LCD over LCD, and the reason that we selected all of the factors, was so that when we get to this step, the fractions will be eliminated. They'll get divided out. Okay? So here's our first term, this yellow-green. The a squareds cancel out, so that's nice. And our first term is left with just that b to the third. Cool. Our second term, we're gonna lose this b, and this will turn into a b squared. Alright. Our next term, this a goes away, and this squared goes away. This turns into an a. Okay, so we have an a times b to the third for this term. And in this term, we have a negative. This b to the third cancels out with this b to the third. So we have a minus 5a squared. So I'm gonna go ahead and write that. I got a b to the third here. I'm adding an a squared, b squared. All right, and then down here I've got an a and a b to the third. And down here I've got minus 5a squared, which is a lot simpler. At least it has positive exponents. Okay. Okay, looks like I can fun with factoring. I can factor stuff out of here. And it looks like I could factor stuff out of this one too. I don't quite know. I think she just got her final answer. Okay, cool. So that is the final answer. But again, you could factor out a b squared from here. And if you did this on your homework, your quiz, or your exam or whatever, and continued to factor this, even though the stuff you're factoring out may or may not cancel, it's gonna be the same answer, okay? Or it's gonna be the same value, and you'll get credit for it. So what I'm gonna do here, and I'm just gonna do it right quick so you can see what happens, minus 5a. Okay, so I factored out what I could from the top and the bottom, and nothing cancels out. That's cool. I can leave it this way. I could have left it that way. Either one. Go ahead.
I can't figure out how to put it into words, so.
Okay.
Do you have to factor completely, like, what if you did?
This guy, you mean? So yeah, that was what I was trying to explain. If I tell you what, if you could cancel something else out by factoring all the way, if I could cancel something out here, then yeah, you should. But if you can't cancel anything out, you don't have to factor anything else
Well,
out.
what if you did, instead of factoring b in the second numerator, what if you just did b, and then you have b in the second plus a in the second b,
You could do, yeah,
and then, oh wait, but then it would,
yeah,
Never mind.
it's
It was
still
gonna
not
be-
gonna cancel.
you're right.
It's still not gonna cancel. So either one works. Doesn't matter. If I could factor out a b squared out of the top and a b squared out of the bottom so that they would cancel, you should do it.
Yeah, that's,
Yeah, but if you can't cancel anything out after you factor, then either way, it's okay. Doesn't matter.
could you not have, could it not be like b and then b squared and then plus, no, never mind, I answered my question.
Yeah, so,
If it's-
I'll just answer you can't talk about it question, but I'll answer it. There's nothing you could factor out of the top and the bottom that will cancel. There's nothing. You can factor it, but you can't cancel anything out, so there's kind of no point. You can do it if you want. Does that help?
Yeah.
Yeah, the purpose of factoring stuff is to cancel stuff out, so. If you can't, then don't bother. Okay. Are there questions on what happened here? Excellent. If there are questions, raise your hand. We'll talk some more. Okay. Okay, so a couple of different methods, all right? This is what we learned today. Figure out the LCD for every single one of these denominators. I got a 1, I got an x squared, I got an x already covered, x squared already covered. Therefore, my LCD is that for the whole expression, okay? I take that LCD, I multiply it, I rainbow it in to every one of these terms. This is my third step, rainbowed into every term, stuff cancels happily, I factor what I can, cancel stuff out, and I get an answer, okay? Now I can go through and walk through every bit of this, but the purpose of this slide is to show you these two methods. So this is what we've been working on today, multiplying the LCD up top and bottom to cancel out those complex fractions. Okay, here's my x squared canceled out. Here's an x canceled out. Here's my x squared canceled out. To leave me with something that's a little bit easier, no fractions. Then I continue, like we've done in the past, to factor the top, factor the bottom, then cancel things out and come up with a final answer. Now, we can do this another way, which is what we were doing yesterday at last class on Monday, day 15, which is we address each of the numerator and the denominator, we address them separately, okay? And by that, I mean we take the numerator only and we find the LCD up here, and only and find the LCD down here. Actually, let me just do that. What's the LCD up top and what's the LCD down below? They happen to be the same thing, but they don't always have to be, okay? We find the LCD up top, we combine those fractions together up top, and then we find the LCD down below, and we combine those fractions down below, and it looks like this. We've done that in the past, okay? Where we combine these fractions, we address them entirely separately. Here's one ball game, here's the other ball game. Wish I didn't do that one. Okay, this is what we've done in the past. This method is you can tackle each of these separately, okay? And it still comes out to the same answer. It's just harder to get there. I'm gonna say harder, but there's more steps, okay? Today, we learned about LCD for the entire problem, not just the numerator, not just the denominator, but the entire problem. And multiplying that through gets us to the answer a lot more quickly. This is what we had in the past, and this is today. Okay? Just showing you that today is better. The future is bright. Okay? So, does anybody want me to walk through what we did in the past? Combining these fractions using the LCD. Because I can do that. Okay? We've got a single fraction up top, a single fraction here. When we have a single fraction and we're dividing by a single fraction, we take the second fraction, flip it, and multiply across, cancel stuff out, and we get to the same answer after a lot more work. This is the shortcut. Okay, how are we feeling about today? A little wishy-washy, kinda. A little practice will help. Okay, okay. This concludes the show, because I will not be back here after spring break. But I will be here for the next hour and a half. So we can talk about the practice quiz if you'd like. You do have a quiz for you on your desk, quiz 14, or quiz 15.